See this guy? A half protruding bushing? This guy was too much for bushing puller Mark 1.
Why are we still here? Just to suffer? Every night, I can feel my leg.
Anyway, the point is that bushing puller Mark 1 died, so I'm going to make another one. A simple device consisting of a pusher, a pipe, and a fancy washer. A pretty simple device. The pusher is pulled through the chassis when the threaded rod is tightened, driving the bushing out into the piece of pipe. Bushing puller Mark 1 failed in the thread. It was based around a small Acme thread, probably about 10mm, so quite small, but probably made from good high tensile steel. This version is using an M12 thread, so quite a bit thicker, but this is just cheese grade. I could use M14. 14mm will fit through the bushings, but 14mm is not a common size for some reason. I can get 14mm threaded rod locally, but only a very expensive high tensile length. So I'm hoping this cheap 12mm rod will get the job done. That's pretty tight. Nothing yet. Still nothing, and I'm leaning on this breaker bar pretty hard. I really expected it to pop by now. You can see I'm bouncing against the 2-foot breaker bar. Now I can definitely push harder than this if I wanted to, but I can tell stuff is already breaking rather than turning. Let's see what's going on. Ah, stripped threads. Well, I have plenty of threaded rod left, so let's cut a fresh length and try another bushing. This is the other front side, and it's the same deal. It doesn't feel like it's going to budge. I haven't pushed the thread to breaking point yet. Let's try a rear bushing first. Nothing. I don't feel like spending a fortune on larger threaded rod. If it was guaranteed to work, I would, but I don't think any of these bushings are coming out without a fight. So let's turn things up a notch. The reason I would rather not do it this way is because, as you can see, you need to cut out the outer shell of the bushing, and inevitably you're going to mark the chassis doing this. There's not really any consequence to that, except that it's a little shoddy. Anyway, let's get the other three out. The other item that needs prying out of the chassis is the steering relay. The steering relay is a simple contraption. You turn the steering wheel, and the steering box pushes an arm that turns the top of the steering relay. And the relay is simply a shaft that runs through a couple of bushings. The steering arm attaches to the bottom, which pushes the front wheels one way or the other. The relay itself is a good simple design. However, the method Land Rover used for holding it in the vehicle is less ideal. You see, they basically just jammed it into a hole. I'll just point out that I already have a new steering relay, so I'm not concerned about bashing the old one with a hammer. I have to get it out of the chassis. These are jammed in, a bit like a tapered wedge. You can see a tiny bit of movement if I bash the top sideways. That means there's hope it'll come out. The bushing removal tool was a bit of a waste of time, so for the steering relay, I reckon we skip straight to the backyard method. So I've got two 2-ton lifting straps hooked around the jack, and I'm pushing pretty hard on the handle. Now there's a lot of force going through the jack. I can swing off the handle right now. If I give it a little tap tap, I think it's coming up. Look at the bolt hole. That definitely isn't lining up anymore. I can't believe it hasn't popped yet. Let me put a bit more into the jack. Ah, there she goes. Easy. Well, this is proving to be a little bit annoying. You guys who have done this before can probably recognise what's going on. Okay, I give up. Now you can see why I wasn't too worried about cutting into the chassis. It's going to need some fabrication anyway, because this is part of the chassis. The steering relay didn't let go of the chassis, we just tore the chassis apart. The welds along the bottom of the cylinder were less strong than the crusty rust holding the relay in. So this cylinder forms a hole through the front crossmember, and the relay sort of jams down into it. The relay is actually held in place by a separate collar on the bottom and via these bolt holes at the top. But this bottom inch or so is jammed into the cylinder. The flaw in this design is that it's only the bottom inch of the relay that's machined to be a close fit. The rest of the casting is recessed, and that recess is open to the elements, so it just fills up with water, and then this happens. So anyway, I've got a hole to deal with. The normal way to deal with this would be to chop out the front crossmember and replace it. And I would have done that, but there are 0 new front crossmembers in New Zealand, so I have to fix what I've got, which is fine by me. The hassle is that it's not as simple as you might think to replace the cylinder. There is no nice pipe size that'll work, and even if there was, I'd have to buy a 6-metre length of steel. Machining a solid piece of round would work, but that's too much for my little Myford. Basically, replacing that sheet metal cylinder is a hassle. So I'm not going to do it like that. This is the new relay. As I mentioned, it's only this bottom inch or so that is held tightly in place by the cylinder. I have meters of the square stock lying around, and it pretty much covers the machined portion of the relay. So I'm just going to turn this stuff into a round hole, and figure the rest out later. What I'm aiming for here is a very slight interference fit. And it feels pretty good. It could do with being a little bit looser, but I'll worry about that later. It's probably going to warp slightly when I weld it in anyway. Speaking of welding it in, that's where it has to go. I don't have a plan beyond this point, so I'm going to clean up the bottom to better see what we're working with. This edge is the seam where the cylinder was welded. As I ripped that out, it pulled quite a dent. You know what? That's better. Let's start from fresh. To start with, the big chunk will be welded onto this bottom plate. Now the weld I'm going to put into this rebate is more to seal the gap rather than to hold everything together. This is exposed on the underside of the chassis, and I don't want water and gunk tracking in between the layers of steel. If I just go and blast weld in here, the bore will definitely warp. So I'm being really careful. One tack at a time, followed by compressed air to cool everything down. And I got sick of the air compressor and switched to a wet rag, which works just as well, so long as wherever you're pointing the gun has had time to dry. And it still fits pretty well. And I'm thinking, good job, pal. About now, I realise my mistake. I'm dropping the relay in place, just to see that it sticks up perpendicular to the chassis. Now, I'm only lightly tapping the end of the shaft with a leather face, but I don't know exactly what the inside of the relay looks like, so perhaps I shouldn't even be doing that. Anyway, don't copy me. The fit is still a little tight. I want to be able to see the relay sitting right down in the bore, and I don't want to bash it in. So I may as well loosen the fit slightly before going any further. And everything looks nice and square, so let's weld the bottom in for good. So, originally the cylinder that wrapped around the relay was welded to the top and bottom of the crossmember. The chunk of steel I machined a bore into is way stiffer than the sheet metal cylinder would have been, but I do want to tie the top and bottom together. That's what these little stiffeners are for. They turned this end into quite a stiff little box. I would guess that this is more rigid than the original design. Plus, it's not going to trap water, and everything is open for future rust proofing. Here I'm trying to position the top plate so that there's an even gap around the relay. That's not super critical, but it may as well be right. The welding is done now, so far as holding things together, but I am going to build up the corners, just so that we end up with a nice square edge, which matches the original welds a bit better. don't have the bottom fixing collar, which bolts up to the underside of the crossmember and holds the relay in place. I'm pretty sure it doesn't have any effect on how high the relay sits, but I'm going to leave the top brackets tack welded for now, just in case. Next time I order parts, I'll get a new collar and finish the welding. But for now, that's it. This isn't the end of chassis repairs though. There's more. There's always more. So I'll see you later.